Welcome back to the course Introduction to Green Process Engineering. Today we will focus on polymers, specifically which measures are taken within the regulatory framework of the European Union. To meet the zero-emission goals of the European Union, a shift of the polymer industry towards sustainability and circularity is needed. The transition path follows three strategic pillars, namely, to make plastics circular, to drive life cycle emission to net zero, and to foster the sustainable use of plastics. Plastics are strategically important materials for the European economy, with applications in almost every sector, including automotive, construction, packaging, consumer goods, healthcare, and renewable energy. Let's check what is behind the three pillars, starting with the circularity of plastics. Circularity is one of the fastest, most affordable, effective, and reliable method for reducing greenhouse gas emissions from the plastic system, and a key driver for the emission reduction in the short to medium term. This picture summarizes the circularity of plastics. As you can see, at present the main feedstock are fossil resources. Therefrom, base chemicals, meaning monomers like ethylene, are produced before the polymerization takes place. They are then manufactured to plastic products. Our daily life is full of plastics. You may take a minute and check how much plastic you have just around you in this moment. And don't forget about the synthetic fibers that might be in your clothing. You already know the concept of circular economy, hence reuse and retail are clear to you. The collection and sorting is the next step in our plastic circle. After that, the recycling process starts. We will have a closer look at each technology. The arrow width shows the mass of material, hence only little fresh feed material is fed into the plastic cycle. Mechanical recycling requires single-strain polymer. Therefore, the collected plastic is sorted before further recycling. As an example, you can see here the recycling of polypropylene. The input is already sorted polypropylene, which is shredded, then washed and milled. In a float sink, the plastic is separated from impurities before it undergoes drying processes. This is followed by compaction, and finally, by extrusion, polypropylene pellets are achieved. Mostly, these pellets have a lower quality than virgin plastics. To achieve higher quality, the pellets from extrusion can also undergo the so-called physical or solvent-assisted recycling. Here, the pellets are washed with a solvent and further purified before extrusion. This recycling path ensures high quality of the recycled material. In chemical recycling, the polymers are broken down to the monomers. To break down polymers to the single monomers, pyrolysis or gasification are performed. As an example, you see here the flow scheme of plastic pyrolysis. Pyrolysis can handle mixed plastic waste. However, each process is easier the purer the input material is. After collection, sorting, washing and shredding, the plastic waste undergoes pyrolysis, which is performed at temperatures between 300 and 900 degrees C, resulting in a carbon-rich char and a pyrolysis oil. After purification of the pyrolysis oil, it is fed into the steam cracker of the conventional refinery and the processing of virgin material starts again. Challenges are in the purification of the pyrolysis oil, as non-process elements such as chlorine from sodium chloride or nitrogen from proteins can occur, which are both toxic for the cracker. You can have a look at where plastic recycling plants are located in the European Union by checking the webpage of the European Commission. The future way of plastic production will also include the utilization of captured carbon. Here you see carbon dioxide as an input material that is processed to syngas via the reverse water gas shift reaction. Either directly or through methanol, olefins are produced, which are then further polymerized. The process steps generally use catalysts. This is also where a lot of research still is performed to find ways of decreasing reaction temperature and reaction time. In conclusion, today we focused on polymers. First, I showed you that plastics play a major role in industrial processes, but also in our daily life. Then, the circularity and 3 ways of plastic recycling were discussed, before illustrating how plastic will be produced in the future based on captured carbon. Thank you very much for watching, and see you again in the next video.